We're all familiar with the weather here on Earth and the countless ways it affects our lives every day. But a lot of people don't know that there's a kind of weather in space too. And the effects of space weather can be just as important to all of us. Where does space weather come from?
The sun. The sun is constantly giving off streams of energetic charged particles. We call these streams the solar wind.
It's not really wind since there's no air in space. But these charged particles are bombarding the Earth all the time.
And occasionally, a storm on the sun sends a huge amount of particles our way. And the effects of these on orbiting spacecraft, power stations, and even people can be devastating. I think I'll go inside.
Although our local star, the Sun, is located about 150 million kilometers away, we are bathed in its light and heat radiation, both of which are necessary for sustaining life on Earth. But sometimes, the Sun gets more active and throws off what scientists call a coronal mass ejection, or CME. One CME can contain millions of tons of plasma, a hot gas made up of charged particles. If the CME just happens to be aimed toward Earth, its power can cause tremendous damage, including massive power and cell phone outages and disruption of radio and GPS signals. Satellites in orbit have been rendered totally useless by incoming CMEs, and an astronaut caught in orbit during one of these events can be in grave danger. Dr. Nikki Fox is the project scientist for the upcoming Radiation Belt Storm Probes mission. She's made a career of studying these storms from the sun.
If the sun is very active, it can be having a lot of solar flares, a lot of bright flashes, can be sending out a lot of energetic particles. We can even have big solar storms, and they are going to impact the Earth. So we want to be able to predict, in the same way that you would protect yourself with an umbrella, we want to be able to provide some protection for the spacecraft and for our astronauts up in space.
Luckily, our planet is surrounded by a huge magnetic field that extends outwards into space and gives us some protection from solar storms. Instead of penetrating the atmosphere, the solar wind particles cause changes in Earth's magnetic tail, channeling particles into the polar regions and ultimately creating the brilliant auroras that appear in the sky near the North and South poles. But beautiful as they are, not all the energy ends up in a lovely celestial display. In 1989, a particularly strong solar storm sparked an equally intense geomagnetic event. Geo meaning Earth and magnetic because it interacted with the Earth's magnetic field. The result was a power outage that covered much of Canada and the northeast US, and an unusual aurora that extended as far south as Texas.
The power that comes into your home is AC, alternating current, but the aurora is a DC, it's a direct current, so it causes big problems for a grid that is set up to have AC current bouncing back and forth, and you put a big current straight through it.
Today we have a fleet of space and ground-based systems that keep a close eye on the sun and warns us whenever potentially damaging storms are headed our way.
And even more spacecraft are due for launch in the near future to help us keep tabs on our neighboring star. The Radiation Belt Storms Probe mission, or RBSP, will launch 2 nearly identical spacecraft in 2011. These orbiting twins will sample the harsh radiation belt environment around Earth, where major space weather activity occurs. Researchers studying space weather look for mathematical trends in data gathered by spacecraft, as well as instruments on the ground. Using fairly basic calculations, scientists study gradients in solar wind data and track these changes over time. The size of a particular menacing magnetic storm can be determined by multiplying the speed of the solar wind by the time it takes to pass over an observing spacecraft.
All it is you take some particles, you see how energetic they are and how many of them there are, we call that the flux, and you multiply that with the magnetic field that's up there, and that gives you a whole different component, something that you can't actually go up and measure. You couldn't design an instrument to go up and measure phase space density, but by combining 2 instruments on board the same spacecraft, taking those measurements at the same time, math allows us to be able to find something that we couldn't do if we were just relying on our instruments alone.
So, even though it's somewhat temperamental, we can still live with our neighborhood star. In fact, we can't live without it.
We just have to keep an eye on its activities. Before we had satellites and humans working in orbit, space weather wasn't much of a concern. But as we move forward into our high-tech future, venturing further away from our earthly home, understanding and predicting space weather will become more important than ever before.